All right, let's talk about the exponent rules. So the first rule right here is the product rule. Now, the word product in mathematics means multiply. And you probably know that when you perform the product rule, when you multiply the same bases, you're actually adding the exponents. So don't be fooled by the word product. It's really a multiplication problem, but you will use addition. Now here's why you add those exponents. So this is x to the fifth times x to the third. Let me write it out the long way. 1, 2, 3, 4, 5. X to the fifth is like taking x times itself 5 times. Times x to the third. X times x times x. And when you look at this, if you put them all together, how many x's do you have? 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. Okay, so x to the fifth times x to the third is x to the eighth. Okay, and you're going to learn that using the product rule, if you have the same base and you are multiplying, you're going to end up adding the exponents. So you could rewrite it like this: x to the 5 plus 3. All right, now let's talk about the power rule. Right here, the power rule. So this is z to the third to the fourth power. And once again, let me write it out the long way. You could write this as z to the third times z to the third times z to the third. There's 3 of them. Here's the fourth one, times z to the third. And you'll notice what you learned from the product rule, or if you counted them up, you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You would end up having z to the 12th power. Okay, now let's look at the original problem, and you can come up with a rule. Look right here. What do you think you do with that 3 and that 4 to get 12? Okay, and the answer is to multiply them. So this could be written z to the 3 times 4. Okay, this one's called the power rule, and you get z to the 12th. Okay, it brings us down to this rule down here, the power of a product rule. The power of a product rule. And you can see that we have a product inside, right? These things are multiplied, and they are taken to a certain power. So the longer way to do this, which is the way that I prefer, is going to be to write this out twice. 5a to the third, b to the fifth, times 5a to the third, b to the fifth. Okay, so I wrote it out twice. Now, if I rearrange this, since everything is multiplied, this is what it would look like. It would look like 5 times 5, a to the third times a to the third, b to the fifth times b to the fifth. Okay, and you will end up getting 25, a to the sixth, b to the 10th. Now, with the power of a product rule, what you can learn is that you could do it like this. You could take each one of these bases in the inside and apply this exponent of 2. So another way to look at it would be like this, to say 5 to the second power times a third to the second power times b fifth to the second power. Okay, and then you'll notice you get the same thing. Notice how this becomes power rule. Here's the power rule, here's the power rule. Okay, so you would still get 5 squared is 25. A squared, a to the third to the second power is a to the sixth. b to the 5th to the 2nd power is b to the 10th. Okay, so you get the same thing, right? Okay, and that brings us to the last rule up here, which is the quotient rule. Now I'm going to tell you, I don't like using the quotient rule. Okay, it only works if your numerator is greater than your denominator. The quotient rule says that if you have the same basis, that you can subtract the exponents. You could take the 17 minus the 2 and get 15. But I like to write it out and cancel. So I know this is going to be a little bit long, but I'm going to write out my 17 m's on the top and my 2 m's on the bottom. Okay, so if you have your 17 m's on the top and 2 on the bottom, in the denominator, you're going to notice that 1 on the numerator will cancel 1 on the denominator, 1 on the numerator will cancel 1 on the denominator. Now, how many are you left with? And the answer is going to be 15. So my answer here is m to the 15th. Okay, but I like to look at it as canceling out rather than subtracting. Because what would happen if you had this? What would happen if you had x to the 3rd over x to the 7th? Right? Now, if you're subtracting, you end up with a negative exponent. And I know you don't want that. So if I write the 3x's out here, 6, 7 x's down there. Now, when you go to reduce, anything in the numerator will cancel with anything in the denominator. That's the same. And you notice in this problem, what do we have? 4 x's, and where are they? Are they up here in the numerator? No, they're down here in the denominator. So the answer to this question, simplified version, will have 4 x's on the bottom, and then you have a 1 in the numerator. Okay, that 1 up there is a placeholder. Truthfully, it's the coefficient that was right here, that was right here. Okay, that's all the exponent rules.